Short tutorial on using MATLAB for building arrays, conducting array manipulation, doing some simple plotting, and using built-in MATLAB functions. Let's get started using an example of the ideal gas heat capacity constants. So the ideal gas heat capacity, or specific heat, is often modeled as a function of temperature. Ideal gas heat capacity, or specific heat, is given by Cp in units of joules per Kelvin mole. And it's given by this equation where A through E are constants and T is temperature in Kelvin. So you can see different gases listed here. If we scroll all the way down, we can see water and the values for A through E. So let's use these values and try to build a plot using MATLAB of specific heat versus temperature for a range in degrees Kelvin, ranging from, let's say, 0 degrees Kelvin through 1200 degrees Kelvin. Let's get started. So first we want to start with building an array of temperature values. We can do that one of several ways. One way to do that is to give a starting value using square brackets, a colon, the step size, we'll say 1, and go all the way up to 1200, semicolon to suppress that. Another way to do it would be to use the function linspace. Here it would be linspace starting at 1. The final value would be 1200, and now let's say we want 1000 points, 1000 elements in this array. In this case, let's just use t equal to linspace with these inputs. Also notice that I began the script using clear, close all, and CLC. Clear clears the workspace, close all will close any open figures, and then CLC will clear the command window to give you a nice clean slate to start with. Also, notice that this script here is saved as example.m, and that's in the current folder listed here in the directory, desktop, and several subfolders. Okay, so we have T already. Now what we need is, let's go ahead and list the constants for water. It's always a good idea to comment your code. So we'll start out with A. A here is 34.51. I have them written down. B is negative 0.01. C is 4.686 times 10 to the negative 5. So notice that this is another way to write 4.686 times 10 to the negative 5. We can simply use this E. D is equal to negative 3.781 times 10 to the negative 8. And E is 1.173 times 10 to the negative 11. Great. Now we have our equation. Notice all of those match here. Now we want to use our equation. This is the equation. It's simply Cp is equal to A plus B times T plus C times T squared plus D times T cubed plus E times T to the 4th. This is how you think you might write it, and this would work except for one problem, and that is when we use arrays with powers, such as to the 2, to the 3, to the 4, we actually need to use the dot operator because we want this power to be applied to every single index in T. If we use T squared, it would simply do a, without the dot operator, it would simply do a matrix multiplication t times t. That's not what we want here. We want each element inside of t to be squared, to be multiplied by itself. Okay? So now we have our equation here. What we want to do now is plot. We want to plot. Now MATLAB will guide you. It says to give the x and then the y. So our x-axis is t and our y-axis is cp. You can close. Let's run this just to see what happens. So we can see our figure here. On the y-axis we have heat capacity, specific heat, and on the x-axis we have t. Notice that our values start from 0 or 1 and go all the way out to 1200, which is listed here. And there are 1000 points, 1000 elements between here and there, and then corresponding values for specific heat in each of those locations. Now, as any good engineer will tell you, this plot needs to have a title. We can add a title by using the function title, and let's just call it CP. Notice the underscore here. That will make this P a little lower, how it should be. C sub P versus temperature, and we'll say here Kelvin. Okay, and then we should also add a label for the x-axis. We'll use the function xLabel. Notice the apostrophes here frame the text. Same for xLabel. xLabel, we want it to be T, and this is in the units Kelvin. It's a good idea to include your units on your axes also. Y-label here is C, we'll again use the underscore, P, and the units here are listed over here, joules per Kelvin mole. So joules per Kelvin mole. Close the text or the string, close the parentheses and suppress. And press run, and here we go. Now, let's imagine that we want to find the minimum location, which we know is somewhere around here. We want to know exactly what is the minimum heat capacity for this plot, and at what temperature does that occur. You can do that by using a built-in function called min. You can learn more about min, or any function in MATLAB, by typing help and min, for example, so the name of the function. What we'll notice here is that min will return two things. The first thing it will return is the smallest element, an x. That will be the first element of the returning, that the function returns. The second element will return the indices of the minimum value in the array x. So, how we want to do this then is, we'll leave this blank for now. We'll set this equal to min of CP. So this is looking at the array CP for the minimum value. We want to save the minimum value in a variable called minval, and we want to save its index in a variable called minloc for min location, the minimum location of the minimum. If we run this here and take away the semicolon, we'll see that the minimum value is 33.9, and the location of that minimum is at index 104. So let's create a couple lines to display that. We can call it text, and set it equal to sprint f of minimum CP value occurs at. Now with sprintf, you can use some different kinds of flags. Here we want to input a value, so we'll use the %. 3.1 means 3 places before the decimal and 1 after the decimal, and f for floating point, and then K for Kelvin. Then we'll put a comma to refer back to this, and the value that we want here is the value of the temperature at location minloc. Remember from before, that's index 104. So we close there, suppress that, and then we can display the text. And when we run this code, you should see our plot. Everything looks good. And then here we displayed minimum CP value occurs at 124.6. Again, that